the methods of integral calculus, which we have seen earlier, can be applied to deriving the equations of motion or to analyze the kinematics of motion in a general setting. Whatever be the conditions, the method of integral calculus can be applied. Hi everyone, this is Satish. This is the 6th lecture of basics in kinematics. Today we are going to derive the kinematical equations of motion using integral calculus, particularly for the situation of constant acceleration, that is a uniformly accelerated body. So we start with the expression for acceleration. We know that dv by dt is equal to a. This is the acceleration. In general, this is a function of time, and this can be written as dv is equal to a dt. Now we can integrate both sides. When both sides are integrated, whenever the definite integral is used, you have to take care of the limits of the integral. Here, the limit should be related to the v here or t here. That is called the measure of integration. dv and dt are called the measure of integration. Therefore, the limits of integration are fixed based on the measure which we are choosing in the integral. Here, this is velocity. Therefore, we have to take the lower limit of the initial velocity and upper limit of the final velocity. Initial velocity is the final velocity is represented by the letter v. Therefore, this when integrated will become integral u to v dv. And on this side, this is integral, and here it is time. Therefore, we have to take the initial time and final time. We take the initial time as 0 and final time as t. Therefore, this is 0 to t. And this is a dt. We take the simple case where a is equal to a constant. When a is equal to a constant, this can be written as integral u to v dv is equal to a integral 0 to t dt. And this when integrated you will get v, and the limits are 0 and v. This v is the variable, this v is the final value, but we usually write it by the same letter v usually. This is equal to a multiplied by dt. When integrated you will get t 0 to t, and this will be, the left hand side will be v minus u and the right hand side will be at. T minus 0, that is 0. Therefore, v minus u, or we have the first equation of motion, v is equal to u plus dt. This is the first equation of kinematics. But remember that it is applicable only for the case of uniform acceleration. If a is not a constant, that is, the acceleration varies with the time, you cannot use this relation, but you can use this relation. This is sufficiently general. For example, imagine that a is equal to 3t plus 5. Usually students make a serious mistake, that is they substitute 3t plus 5 here and write the relation v is equal to u plus 3t plus 5 multiplied by t, which is u plus 5t plus 3t square. This is a mistake. You should not make this mistake. Whenever acceleration is a function of time, you have to integrate acceleration also. Therefore, this is wrong. You should not make this mistake. Instead of that, what we have to do is integral 0 to v dv is equal to integral 0 to t 3t plus 5. This when integrated will be 3t dt. When integrated will become 3t square divided by 2. This is 3t square divided by 2. 5 dt when integrated will be 5t. This is from 0 to t. This is from u to v. Therefore, v minus u is equal to 5t. This is 5t plus 3t square divided by 2. It is not 5t plus 3t square. This is wrong. It should be 5t plus 3t square divided by 2. Or we have the formula v is equal to u plus 5t plus 3t square divided by 2. When we use the power series method, we have seen that this can be obtained by the power series expansion that we have seen earlier. But here we are using the method of integration. Remember that u plus at is directly applicable only when a is a constant in time. If a is a variable in time, also you can use this method, but you have to take a inside the integral sign and perform the integration for a also. Here a can be taken out because a is a constant. That is the first equation which we have derived. To derive the second equation, we take the definition of velocity. That is, velocity is defined as the derivative of position, and the same procedure we will be applying there also. That is, dx by dt is equal to v, dx is equal to v dt. We integrate both sides. Here the variable is x, therefore we have to take it from x0, that is the position at time 0, to xt, which is the position at time t, dx, and integral v dt. This is time is 0 to t. But we should be slightly careful here. V is actually a function of time. Therefore, you cannot write v and integrate. Instead of that, you have to write v as the function of time. We know for constant acceleration, v is equal to u plus at. Therefore, this we can write as integral 0 to t u plus at dt. Now we integrate both sides. U is a constant, u dt will give you an ut, a is a constant, at dt will give you an at square divided by 2, and here you have x. Therefore, this is x from x0 to xt is equal to ut plus half a t square 0 to t. This is xt minus x0. This is ut plus half at square. Xt minus x0, according to our definition, it is the final position minus initial position. Final position minus initial position is the displacement, and the displacement of the particle we call as s. Therefore, we have the familiar formula s is equal to ut plus half at square. Remember that this is applicable only when you have acceleration constant. If acceleration is not constant, we have to express v as not as u plus at, but as a given function of time. Will not be a linear function. If velocity is a linear function, then acceleration is a constant. If acceleration is not constant, velocity will be a non-linear function, or quadratic or cubic or four quartic, like that. If we take, for example, v is equal to 2t plus a t square, this is a quadratic function, then the derivative of v will not be a constant. If this is the situation, you have to substitute inside this v, you have to substitute this quantity and then perform the integration. This formula can be applied only for a fixed acceleration or a uniformly accelerating body. Next equation is rather special. We know that equation do not involve time. Therefore, we have to eliminate time. That is, we have dv by dt is equal to a. We can eliminate this t from this expression by using the chain rule, which we have seen in connection with the differential calculus. This can be written as dv by dx multiplied by dx by dt is equal to a. dx by dt is v, this is v. Therefore, this can be written as v dv by dx is equal to a. You can take dx to that side. V dv is equal to a dx. This is to be integrated on both sides. This is v, therefore this is from u to v. This is x, therefore this is from x0 to xt. This when integrated, we will get v square divided by 2 from u to v is equal to a is a constant. Therefore this is a multiplied by x from x0 to xt. Therefore this can be written as v square minus u square divided by 2 is equal to xt minus x0. xt minus x0 is yes. There is an a outside. Therefore v square minus u square is equal to 2as. Thus all the equations can be derived. The three kinematical equations can be derived using integral calculus, and the equations which we have seen, that is v is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to 2as. Those three equations are handy equations when acceleration is a constant. If acceleration is not a constant, you can use the integral formulas described here, but you have to substitute acceleration as a function of time or velocity as a function of time in the expression. Then you will get the correct equations even when the acceleration is not a constant. One of the most important case of uniformly accelerated motion where we can use these equations is the motion of a body near the surface of the earth. That is, when a body falls freely near the surface of the earth, or when a body is rising or near the surface of the earth, we have only one force acting on that is the force gravity. We can have the situation where the particle falls freely or rises free. First, for example, imagine that this is the ground. This is the ground. And here we have a mass m which is falling freely. Falling freely means u is equal to 0. Whenever you say that a particle falls freely, you take the initial velocity to be 0. Then it is observed that by famous Galileo's experiment on the Leaning Tower of Pisa, he has shown that all bodies, irrespective of their mass, reaches the ground at the same time. Therefore, t is equal to a constant. You take this distance to be fixed, yes. Therefore, we have AC is equal to ut plus half at square. U is equal to 0, therefore this is equal to 0. Or you have S is equal to at square divided by 2, or A is equal to 2s divided by t square. Here S is same, T is same for all particles, 2 is a constant, therefore this implies that A is equal to a constant. This particle increases speed when coming down. That means this acceleration is directed downwards, directed vertically down, always. Always acceleration is vertically down. Therefore, we take A is equal to minus g, where g is called the acceleration due to gravity. Acceleration produced by gravity. Gravity is the only force acting on this particle. Therefore, this is called the acceleration due to gravity. Its value we usually take as 9.81 meter per second square, 9.8 meter per second square, or 10 meter per second square, depending on the situation. Usually, in objective type questions, we take it as 10 meter per second square. Sometimes it will be helpful to take it as 9.8. We rarely use 9.81. 9.8 and 10 are the usually chosen values. Remember that this acceleration is always directed down. Therefore, g is always down. Therefore, acceleration is always taken as minus g. When a particle is coming down, it will be coming down and the speed increases. The That means the acceleration is in the downward direction. Same is the case for all bodies projected on the surface of the earth, near to the surface of the earth. When it is far off from the surface of the earth, there will be some variations to acceleration to gravity, which you will learn in your chapter on gravitation. In general, if you have a body here, this body is projected with a velocity u, it will rise to a height. At this point, the velocity will become 0, and this height is called the maximum height, which I am going to represent it by the letter h, and the acceleration is in this direction. A is equal to minus g, and we know that v square minus u square is equal to 2as. Here v square is 0, minus u square is equal to 2 multiplied by a is minus g multiplied by h. Therefore, you have h is equal to u square divided by 2g. This particle will rise to a height of h equal to u square divided by 2g. And we can also apply v is equal to u plus at, v is equal to 0, u, a is minus g multiplied by t. Therefore, we have u is equal to gt, or we have t is equal to u divided by g. This will be the time taken by the particle to reach the maximum height, that is u divided by g. Similarly, this particle will come down, and the time taken by the particle to reach the ground again will be same as the time taken to reach at the top. Therefore, it is freely falling body, it reaches down at this point, and the velocity it acquires. If it is freely falling body, then we have u is equal to 0, v we don't know, s is equal to h, a is equal to minus g, and v square minus u square is equal to 2 minus g multiplied by h. Therefore, u square is equal to 2gh, or we have u is equal to square root of 2gh. This will be the velocity acquired by the particle when it reaches at the ground point. The time taken will be same as u divided by g. If you use s is equal to ut plus half at square in that relation, h is equal to 0 plus half multiplied by minus g multiplied by t square. Therefore, this t square can be written as, this is minus g, this is h, it is coming down. Therefore, we take this as minus h. Therefore, h is equal to half gt square, and therefore t square is equal to 2h divided by g. The time taken t will also be equal to root of 2h divided by g. This formula, this one and this one. If you remember this, it will be very helpful in solving questions. Now we derive a formula for the distance travelled in the nth second of motion. That is, the distance travelled in nth second for unidirectional motion. If the motion is not unidirectional, you simply replace this distance by displacement. That is all. This is distance and displacement will be same in magnitude if the motion is unidirectional. Sometimes there can be the possibility that direction changes. If direction changes, this is the expression for displacement in the nth second. And imagine that you have a particle and it travelled a distance at 5 seconds, like this much distance at 5 seconds. It continues to travel and reach here at 6 seconds. And this is usually called, this is the 6th second. This is 6 seconds, this is 5 seconds, this is the 6th second. In the 6th second, the displacement in the 6th second, this is equal to displacement for 6 seconds minus displacement in 5 seconds. That is S6 minus S5. This is usually written as S sub 6. In general, I have Sn, that is the distance traveled or displacement in the nth second, is equal to Sn minus Sn minus 1. We know how to calculate these relations when A is equal to a constant. We can substitute our equations of motion in this case for a uniformly accelerated body, and we can work out this an expression for Sn that is very useful when you solve problems. Sn is equal to Sn minus Sn minus 1. We know Sn un plus half an square minus un minus 1 plus half an minus 1 square. This is equal to un plus half an square minus un minus u plus half a multiplied by n square plus 1 minus 2n. That is equal to un plus half an square minus un plus u minus half an square. This un and this un will cancel. This half an square and this half an square will cancel, and you will have the formula Sn is equal to u plus an minus half a, or this can be written as u plus a multiplied by n minus half. Therefore, you can write Sn as u plus a multiplied by n minus half, or u plus a by 2 multiplied by 2n minus 1. This formula or this formula, both can be used. And this is a very important relation. If the particle starts from rest and A is equal to a constant, this relation is applicable for A is equal to a constant. Therefore, for particles starting from rest, Sn is proportional to 2n minus 1, where n is equal to 1, 2, 3, etc. They are integers. And this tells you that S1 is proportional to 1, S2 is proportional to 3, S3 is proportional to 5, S4 is proportional to 7, like that. Therefore, S1 is to S2 is to S3 is to S4 is 1 is to 3 is to 5 is to 7, etc. These are odd numbers. Therefore, distance traveled in successive equal intervals of time is having a ratio equal to ratio of odd numbers starting from 1. This was first observed by Galileo for falling objects. The particle is in free fall. Free fall means the acceleration is a constant and initial velocity is 0. Particle is falling. Therefore, when a particle is falling, the distance travelled in the first second bears a constant ratio with the distance travelled in second. That bears a constant ratio with the distance travelled in the third second, like that. So we can simply write S2 by S1 is 3 is to 1. S3 by S2 is 5 is to 3. S4 by S3 is 7 by 5. Like that. That is first observed by Galileo, and it is usually called the Galileo's rule for odd numbers. Now we work out few examples. First one, a ball is thrown upwards with a velocity of 20 meters per second from the top of a building. The height of the point from which the ball is projected is 25 meters from the ground. How high will the ball rise and how long will it be in the air before the ball hits the ground? Take g equal to 10 meters per second square. So, I took this is an example problem from your NCERT textbook. I took this to simply to make you understand certain peculiarities of the coordinate system. That is, in order to work out this type of questions, you should be aware of the sign of the distances. That people usually make mistakes. Therefore, you consider a coordinate system like this. this is the ground and this is the building, and you take this point as 0 origin, you can take any point as origin, the answer will be same. But I take a point on the ground as 0. And then this distance is given as 25 meter. And from here, a ball is projected up in this direction with a speed of 20 meter per second. Therefore, this 20 meter per second is your u. And it rises up and reaches a height which is the maximum height, which we call as h. Therefore, this point is h. The characteristic feature of the maximum height is at that point the velocity in the vertical direction will be 0. Because if that velocity is non-zero, it will still rise to a particular height. This height is maximum. That means the particle is at rest there. Particle goes from here. There is an acceleration in the downward direction. So the speed decreases and reaches 0 at the maximum height. Therefore, we have v is equal to 0 here. And acceleration a is equal to minus g. That you are asked to take as minus 10 meter per second square. First we calculate h. For that, we use the formula v square minus u square is equal to 2as. Because we are not given the time. V square is, v is 0, therefore this is 0, minus u square is equal to minus 2 multiplied by minus g multiplied by s is equal to h. You remember that this is 0 and this is the starting point, that is 25 meter. From there it moves to h. Therefore, the final position is 25 plus h and the initial position is 25. Therefore, the displacement is the final position minus initial position, that is 25 plus h, 25 plus h minus 25 is equal to plus h. Therefore, here this height is plus h based on our coordinate system. Whatever be the coordinate system you choose, this will be plus. And this is minus u square, this is minus 2gh. Therefore, we have to calculate h. h is equal to u square divided by 2g. If you remember the formula which we have developed earlier, this formula is directly given. If you remember this formula, you can directly apply that. h is equal to u square divided by 2g. Now, h is equal to u is 20 square, u square is 20 square divided by 2 multiplied by 10. That is equal to 20 multiplied by 20 divided by 20 equal to 20 meter. Therefore, the maximum height the particle rises will be 20 meter. So this is the answer. Now we take the second part. Second part asks you to calculate the time taken by the particle to start from here, go like this, come back and reaches in the ground. There you should be very careful because people usually take this s as 25 meter. That is wrong. Because the final position is equal to 0. Initial position equal to 25. And the displacement AC is equal to final position minus initial position, that is 0 minus 25 equal to minus 25. Therefore, don't forget to write s as minus 25 in the expression. We have to calculate t, therefore we use s is equal to ut plus half at square. A is equal to minus g, s is equal to minus 25, u is equal to 20. Therefore, this s is equal to minus 25. This is 20t plus half into a is minus g, that is minus 10 t square. That is minus 25 equal to 20t minus 5 t square. That is 5t square minus 20t minus 25 is equal to 0. This is a quadratic equation, and a quadratic equation will have two solutions and we have to evaluate the solution. Here this is a simple situation. You can cancel the common factor 5 and write this as t square minus 40 minus 5 equal to 0. Either you can use the formula minus b plus or minus root of b square minus 4ac divided by 2a, or you can factorize this. This is easy to factorize because this is minus 5, this is minus 4, minus 4 multiplied by 1 will be minus 5, minus 5 plus 1 will be minus 4. Therefore, this can be written as t minus 5 multiplied by t plus 1 equal to 0. Therefore, t is equal to 5 seconds and t is equal to minus 1 second. Minus 1 second is the time before t is equal to 0. T is equal to 0 is the time at which we have projected. You are asked to calculate only time after the projection. Therefore, you can ignore this minus 1. Therefore, our answer is t equal to 5 seconds. This is the answer. So that is a good question. Now we take the second question. A ball is thrown upwards from the ground with an initial speed of u. The ball is at a height of 80 meter at 2 times. This time, the time difference being 6 seconds. Find the initial velocity g equal to 10 meter per second square. Therefore, a ball is thrown from the ground with an initial speed u, which we have to calculate. It goes up like this and comes back. At a height of 80 meter, the particle has 2 times. That is, at this point the particle goes up at 80 meter. Let this be t1. It goes there and comes back. Here the time is t2. And you are given that t2 minus t1 is equal to 6 seconds. You are asked to calculate u. U is to be calculated. And we know that if we take s is equal to ut plus half at square, here this is the initial position, that is 80. Final position, that is 80. This is initial position. Therefore, the difference is yes, that is plus 80. Therefore, this is plus 80 is equal to ut plus half into a is minus 10 t square. That is 80 is equal to ut minus 5 t square, or 5 t square minus ut plus 80 equal to 0. This is a quadratic equation in T, and we will have 2 solutions. And you should understand that in this type of situations, one solution will give you T1, that is for 80 meter. Second solution will give you T2. And the solution of a quadratic equation is minus b plus or minus root of b square minus 4ac divided by 2a. This is of the form ax square plus bx. Therefore, here a is equal to 5, b is equal to minus u, c is equal to 80. So we can write these solutions. T1 will be equal to minus b is u, minus of minus u, that is u. T1 is the first time, therefore this minus sign is the first time, minus root of b is u, therefore this is u square, minus 4 into a is 5 and c is 80, therefore divided by 10. This is T1. Similarly, T2 will be equal to u plus root of u square minus 4 multiplied by 5 multiplied by 80 divided by 10. You are given that this difference is 6. Therefore, you subtract this from this. When you subtract that, u will cancel and this will become plus. This is plus. Therefore, 2 multiplied by this. 2 root of u square minus, this is 20 into 80, that is 20 into 80 is 1600, divided by 10 is equal to 6. Remember that these times are T2 and T1. They are the two solutions of these equations. Therefore, the difference means the difference between the two solutions. If you call one solution as alpha and other solution as beta, the difference will be alpha minus beta. In quadratic equation chapter in your mathematics, you have the expression for alpha plus beta and alpha beta. If you want, you can use the relation for alpha minus beta also. But this is easier. So, 2 root of u square minus 1600 is equal to 60. Root of u square minus 1600 is equal to 30. You divide 60 by 2. Therefore, u square minus 1600 is equal to square of 30, that is 900. Therefore, your u square is equal to 2500, 1600 plus 900. U is equal to plus or minus 50. There are two solutions. One is u is equal to plus 50 and other is u is equal to minus 50. But you are told that the particle is projected up. When the particle is projected up, the velocity is positive. Therefore, you don't need to take this negative value. Therefore, this negative value you can neglect, and you can write u is equal to 50 meter per second. And this is the answer. Last question. A particle accelerates from rest at a constant rate alpha for some time and then decelerates at alpha and comes to rest. Therefore, the acceleration is beta. It starts from rest, accelerates by alpha, reaches a value, then decelerates, reaches 0. Accelerate alpha and the deceleration is beta. It comes to rest. The total time of journey is t. Find the maximum velocity and the distance. Therefore, we have a particle here. It starts from rest. Therefore, velocity is 0. Then it accelerates by alpha, reaches a value v, that is the maximum value. Then it has a deceleration beta and reaches 0. This time is t1, this time is t2, this distance is d1, this distance is d2. We are given that t1 plus t2 is equal to t. Therefore, we have the knowns in this question is alpha, beta and t. And you have to calculate v, the velocity and the distance d. In both these cases, we have to express the answer in terms of alpha, beta and t. Therefore, first we calculate the velocity. We know that the initial velocity is 0, time is t1, final velocity is v. V is equal to u plus at. Here, this is v, u is equal to 0, a is equal to alpha, this time is equal to t1. Therefore, we have t1 is equal to v divided by alpha, or v is equal to alpha t1, or t1 is equal to v divided by alpha. Similarly, in the second case, the final velocity is 0, initial velocity is v, acceleration is deceleration, therefore that is minus beta t2. Therefore, t2 is equal to v divided by beta. T is equal to t1 plus t2. We are given that the total time is t. Total time t is the known value. Therefore, t1 plus t2 is equal to t. And t1 is this, t2 is this. Therefore, this is equal to v multiplied by 1 by alpha plus 1 by beta. Therefore, t is equal to v multiplied by alpha plus beta divided by alpha beta. Therefore, we have our answer v is equal to alpha beta t divided by alpha plus beta. This is the answer. In your question, if alpha, beta and t are given, say alpha is equal to 2 meter per second square, beta is equal to 3 meter per second square, total time is equal to 10 seconds, then you can use this to calculate the value of v. Here we are writing it in terms of alpha, beta and t. Now we can calculate d1 and d2. We know that the s will be equal to ut plus half at square and v square minus u square is equal to 2as. Here v, u and a are known. Therefore, we have to use the formula v square minus u square is equal to 2as. So we use the formula v square minus u square is equal to 2as. In the first case, this is v square, u is 0, acceleration is alpha and the displacement is d1. Therefore, you have d1 is equal to v square divided by 2 alpha. And in the second case, u is equal to v is equal to 0. Therefore, 0 minus v square is equal to, acceleration is minus beta, it is deceleration. Therefore, minus 2 beta, distance is d2. Therefore, d2 is equal to v square divided by 2 beta. And d is equal to, this is what we have to calculate, that is d1 plus d2 is equal to v square by 2 multiplied by 1 by alpha plus 1 by beta. Therefore, d is equal to v square divided by 2, this is alpha plus beta divided by alpha beta. But we know the value of v, that you substitute here. For d will be equal to alpha square beta square t square divided by alpha plus beta square multiplied by alpha plus beta divided by alpha beta, and there is a 2 here, v square by 2. Therefore, this 1 alpha beta will cancel, 1 alpha plus beta will cancel, and then you can write that result as v is equal to, this is d is equal to, that is what we have to calculate, d equal to alpha beta t square divided by, this is 2 alpha plus beta, and you have expressed your distance in terms of the alpha, beta and t. If you are given alpha, beta and t, you can substitute that to calculate the distance. So, this is the examples which we are considering, and in the next lecture, that is lecture 8 in basic kinematics, we will be discussing the relative motion in one dimension and few examples. All the problems which has appeared earlier will be dealt with in lectures 9 and lecture 10, and that will complete the study of kinematics in one dimension, that is your chapter on motion in a straight line. Thank you.